Hello everyone. Today we are going to discuss the swern oxidation. This is the very important topic for the CSR NET exam and also for the semester exam. Here you can see that in this swern oxidation, the dimethyl sulfoxide is present, the anhydride is present, as well as the oxalyl chloride is present. So we will have the anhydride or we will have the oxalyl chloride, which is act as an activator for the dimethyl sulfoxide, and here we have trimethylamine is present. The swern oxidation is an industrially viable reaction, and it will convert the primary and the secondary alcohol to the carbonyl compounds. This is the one of the most important point, is that this is the industrially viable reaction. The secondary alcohol is prepared over the primary alcohol. So there will be a no over-oxidation with the primary alcohol. The primary alcohol get oxidized to the aldehyde. There will be a no over-oxidation, and the double bond and the triple bond which is present in the substrate are unaffected. And remember that this anhydride or this oxalyl chloride is act as an activator for the swern oxidation. This is the general reaction. Here you can see that the primary alcohol is present, dimethyl sulfoxide is present, and the oxalyl chloride is present as an activator, and the temperature for this reaction is the minus 60 degrees Celsius. The temperature is very important. Above the minus 60 degrees Celsius, the reaction is explosive. So this primary alcohol gets oxidized to the aldehyde. Now we will see the mechanism for this reaction. The mechanism for this swern oxidation is somewhat complicated, but you can understand it very easily. Here this carbon is a electrophile, and this sulfoxide will act as a nucleophile. So it will attack over this carbonyl carbon, and the chloride ion will remove out. So here you can see that there will be a positive charge present over the sulfur, and the chloride ion is present here. Now the chloride ion is act as a nucleophile, and the sulfur is act as an electrophile because the positive charge is present over this sulfur atom. So this chloride atom attacked over this sulfur atom. Now there will be a little bit rearrangement of electrons will possible. So here this electron pair is shifted here, and this electron pair are shifted to this carbon atom, and chloride atom is removed here. So there will be a elimination of the carbon dioxide, and the carbon monoxide will happen here. Remember that this chloride ion attacked over this sulfur atom, this bonding electron pair shifted to here, and this electron pair are shifted to the carbon, and chloride ion is removed from this complex. So there will be a elimination of carbon dioxide and carbon monoxide. So here you can see that the chloride ion is present here, and the chloride ion is attached to this sulfur atom, and this chloride atom is present here. So the electrons are presented in the alcohol. The two lone pair of electrons are present in the oxygen of the alcohol. So this will act as a nucleophile, and this sulfur is act as an electrophile. So this lone pair of electron is attacked over this sulfur atom, and the chloride atom is removed. So here you can see that the two chloride atoms are present, and this alcohol group now get attached to this sulfur atom. Remember that. Now this one of the chloride atom will obstruct the hydrogen, so this bonding electron pair is shifted here. This chloride ion obstruct the proton from this alcohol. Now there will be an elimination of hydrochloric acid. Now what happened here? You can see that the one chloride atom is remain as it is, and this is the ethanol, ethoxy group is present, sulfur atom is present, and the 2-methyl group is present. Now the triethylamine abstract this hydrogen, because this hydrogen is acidic. When it will abstract, the nitrogen gets the positive charge. So here you can see that the nitrogen gets the positive charge, triethylamine is present as it is, the hydrogen is present here, and the chloride atom is removed here because it will neutralize the positive charge which is present over the nitrogen atom. So it will remove out from this reaction. Now here you can see that the positive charge is present here and the negative charge present over this CH2 group. This CH2 group abstracts this hydrogen atom, and the bonding electron pair is shifted towards the oxygen, and these electron pairs are shifted towards the sulfur. So dimethyl sulfide is present as a byproduct, and the primary alcohol get oxidized to the aldehyde. But this all will happen when the temperature of the reaction medium is the minus 60 degrees Celsius. Once there will be the temperature above minus 60 degrees Celsius, the Pumerer rearrangement will be carried out. So in the product we will get the methyl thioethers. For this reaction, it is necessary to maintain the reaction temperature, that is the minus 60 degrees Celsius. Now we will see some basic example for this swern oxidation. Here you can see that the primary as well as the secondary alcohol is present here, and both get oxidized. The secondary alcohol get oxidized to the ketone and the primary alcohol get oxidized to the aldehyde. Now in the second example, here the allyl alcohol is present, and there will be no isomerization of double bond will be carried out. Simply the alcohol get oxidized to the aldehyde. The temperature is the minus 60 degrees Celsius. In the third example, the amide group is present. So amide group get oxidized to the nitrile groups. Now the most important point, when the dimethyl sulfoxide is present as well as the oxalyl chloride is present, and the temperature is minus 60 degrees Celsius, the alcohol get converted to the alkyl halide. Remember that the alcohol get converted to the alkyl halide. Here the trimethylamine is absent. So this reaction is known as a Kato-Nakashi reaction. Remember that when the trimethylamine is absent, the alcohol converted to the alkyl halide, and this reaction is known as a Kato-Nakashi reaction. And when the dimethyl sulfoxide, oxalyl chloride and the trimethylamine is present, but the temperature is above minus 60 degrees Celsius, Pumerer rearrangement will be carried out in the swern oxidation.